Hi everybody. In this video I'm going to talk about how to graph linear inequalities, which in very many ways mimics the same principles as graphing linear equations. I first want to extend a thank you to CUDA Software for making these questions available to you and to me to help you out. So with that in mind, let's go ahead and begin with our first question. So it says sketch the graph of each linear inequality. Now normally when you're dealing with graphing lines, you want to remember the principles of graphing. This particular linear inequality is of the form slope-intercept form, which is y equals mx plus b. And just a quick review of how to do this. This is where you begin. It represents the y-intercept. And this represents how you move from where you began, and this represents the slope. Okay, it helps guide the direction of the line and the steepness of it. So with that in mind, let's go ahead and begin. So in my linear equation, my b, or my y-intercept, is this positive 3 here. So I'm going to go up from the origin to 3 and place my point. Then my slope is 2 over 3. And what this is telling me is that I need to go up twice and to the right 3 times from my first point. So doing that will take me from here to the following place. So up 2, 1, 2, and then 3 to the right, 1, 2, 3. My second point is over here, and then I create my line. The line that you create will be one of 2 types. It will be either a solid line, or it will be a broken line or a perforated line. The way you tell is by the inequality. So for solid lines, you'll have greater or equal, less or equal. But for the broken lines, you'll have greater or less without the equal part in it. So in this case, if we look carefully, we can see that I do indeed have my inequality as greater or equal to, and because of that, I have to make a solid line. So that would be something like this. So here's my solid line. Now when you draw the line, you want to be sure to extend it as far as your coordinate plane allows, just because you want to create a good graph. Now, normally we would be done if this was simply slope-intercept form of a linear equation. However, because we're doing inequalities, we have to consider that we have multiple solutions and we have to represent all the possible solutions there could be. And this involves some shading. So when you have, and I'm going to create a division right here, when you have greater, or you have greater or equal, then you shade. Then where you shade is above. So think of greater as above. And when you have less or less or equal, you shade below. Okay? So with that in mind, where I'm going to shade is over here. So I'm going to shade above because this inequality represents something greater. Okay? Greater or equal to this orange line. So I shade everything above that to show this entire area that I have just shaded represents all the possible solutions I could have, all the possible input-output values, x and y values that I could have, which would make this inequality true. Okay, so if I were to pick any value from within this this green shaded area, such as this one here, and this would be -4, 5. If I were to take these values, this x and this y, and I were to substitute it into that inequality, what I would get, or what I should get, is something that is a true statement. And I can prove that to you so you don't think that I'm just making this up. So let's go ahead and do the answer check for this graph, which is always a good idea anyway. So we're going to check a representative point, which is -4, 5. Okay, it's like your ambassador for this graph. And we're going to substitute the negative 4 and 5, and it becomes 5 greater or equal to 2 over 3 times negative 4 over 1 if you wish, and then plus 3. Now, when you multiply, what you get is 5 greater or equal to, this is negative 8 over 3 plus 3. I can go ahead and turn this into an approximate decimal, and that would be 5 is greater or equal to, this would be approximately negative 2.7 plus 3. And if I were to then subtract these two numbers, I would get 5 is greater or equal to, this would be negative 0.3, positive 0.3. Now you have to analyze, you want to analyze this and ask yourself, okay, so I checked my values, negative 4 and 5, and this is the outcome of that. I got 5 is a number which is greater than 0.3. Is this a true or false statement? And the answer to that is that it is a true statement. 5 is indeed bigger than 0.3. And because of that, this one white point inside that green area shows and proves that any of those green points or points within that green zone would also be a valid solution to this inequality. And that's why you shade the entire area. You could also pick a point from the orange line itself and test it, and you would see that it does indeed work. However, a little note to you, you can only do that if the line you drew is a solid line, because you have that equality component in there, and it allows you to pull a point from the line directly as well if you want to check that. Okay, on to the next. So in this example here, I have to do the same thing as I did before. However, the difference is that I need to first understand that the form of this equation, of this inequality is not in slope-intercept form. It doesn't mean that I cannot graph it from this form. I can still find the x and y intercepts. But if you want to practice using slope-intercept form, and this is just another method, you could simply transform it. So I'm going to transform into slope-intercept form, and I'll put slope-intercept form. So slope-intercept form, and the way to do that is simply move the x to the other side. So I'll show you that work over here. So we're going to move the x term to the other side, okay, using our equation solving skills. These two cancel out, and I'm left with 4y is less than negative x minus 4, and then eliminating the 4 from this, what I get as a final inequality is y is less than negative 1 over 4 x minus 1. And just a side note, this negative here can be placed either with the 1 or with the 4. You don't have to leave it on the 1, nor do you have to leave it in the middle. All right, so now we have this all set up and we can graph it. So my beginning point would be this one here, and I go to negative 1, place my point. My slope is negative 1 over 4 if I put the negative on the 1, which means I go down 1, and then I go to the right 4 times. So from my negative 1, I go down 1, and then right 1, 2, 3, 4, place my second point. And now I'm prepared to make my line. The line I make will either be broken or solid, and this time my inequality is only less than, which means that my line will have to be a broken line. We don't have the equal component in there to make this line solid, so I do have to break it up. Okay, then after I put my arrows, I have to decide, do I shade above or do I shade below? And that depends on my inequality. So if we take a close look at it, you can see that the inequality I have is less. And because it's less, it also means shade below. So you want to shade below the line, and I'm going to go ahead and do that. So here it is, shading all this space below that orange line. And it doesn't stop at the borders of your coordinate plane. it continues because a line continues. And for as long as it does, which is infinity, you will have limitless solutions to your inequality. And you could test it again, just like we did in the first example, by grabbing any ordered pair that's within this green zone, anything that's within the green zone, and you can try it, and you'll see that just like last time, it makes the inequality that you have true. But final thought is you cannot take a point from the line itself. And the reason for that is because none of the points are, I should say, the inequality does not allow you to grab any point from the line because the inequality does not have the equal component built into it. And for that reason, you want to leave all the points on this line alone and only test something that's from the green area itself. So I hope this video helped you better understand how to graph linear inequalities and to understand their multiple solutions. As always, please stop by and leave a comment, and thanks for watching. Bye-bye.